In this video we'll show you how we can import a DXF file directly into PartMaster CAM. So the CAM system is open, so if you go to File, Import, Geometry From, and we'll choose that DXF file. The DXF file doesn't contain data about whether it's in metric or imperial, so we need to switch it here. Okay, so that's that file imported. So the first thing to do is the machine setup, and it's here where we check on the safety position and the home position for a rear or a front turret or tool post. So we can start off by defining a tool. So we go to define a tool. So we'll have a standard turning tool, but the included angle on this is 80 degrees. So if we set that to a smaller angle such that we'll be able to machine most of that shape. So we click OK. So that's defined the tool. Now we need to select it for use. So this sets the spindle speed and the feed rate that we want to use, and also if we need to use coolant, we switch that on here. So the tool is now ready for use, and that's in the program operations window here. So we'll do a roughing operation. There's two types: turning, which is towards the chuck, and facing, which is towards the center line. So for this one we'll choose turn, and the thing that it needs is the cycle limits. So these are the two corners of a rectangle where the tool will work between. So we can either type in the values here, or we can choose them from the screen. So if we click on the choose button here, we can just choose where we want to start. So that's the bottom right hand corner of a rectangle, and this is the top left hand corner of the rectangle. So that just needs to be big enough for you to machine the area in question. If we want to, we can leave a finishing allowance on here, and this is where we set the cut depth for that tool. So this is the individual cuts. Okay, so that's machined all of that. The default method of showing the graphics is with the tool center line. If you want to animate the tool, you click here and then run. So here comes that tool. So the blue lines are at feed rate, the red lines are at rapid. This particular shape, because of the curves that are used to create it, it's broken down into a series of very small lines, but it doesn't matter really. Okay, so when you're creating the turning macro, you can specify the area that you want. So for instance, for the two undercuts here, you could specify two different turning operations so that the tool only moves within those areas when it's cutting. Okay, so that's roughed out the shape, leaving the finishing allowance on. Now we can define a different tool. So this time let's choose, say, a button tool. And when we change the tip radius on there, the Z and X offsets are automatically updated. So now we select that tool for use, and we're going to do a profile turning operation next, which is a finishing operation. So there's lots of options available on this, but if we just leave all of the defaults as they are and click OK, we'll see what it wants to machine. So here's that tool cutting round there. Now it may well be that you don't want it to cut down that front face, and you probably also don't want it to machine round to the back face, which is what it will do as a default. But if we just let that run, you'll see what it's doing. The other thing that you can check on is over on the right hand side here, there's a status panel, and that shows you the X and Z movements of that tool. as I say, this is made up, the shape is made up of quite a lot of small line segments. So if possible, when you're creating the geometry for this, if you can use tangential arcs, the processing time will be that much greater. As you can see, it's going right down to the back face there, because that's the extent of the profile. But if we want to stop that doing, if we double click on the ProTurn operation here, and we go to the options tab, we can see here there's a partial machining operation which allows us to specify the spans that go to make up that shape, and as you can see there's 162 of them, but it's difficult to know which is which. So if we just cancel that, with the cursor in the graphics area, if we right click and say number spans, then each of those spans is numbered, as we can see here. So if we didn't want to machine the first few spans, we could say start off at, say, span number 7, and then towards the back here we could stop at span 161. Okay, so double click that, click on the options, click at start at span number 107 and start at, say, a finish at 161. Okay, so if we just switch on centerline mode so that the graphics run through that much quicker. Okay, so we can now see the finishing pass, which is cutting just along that start of the arc there, machines all the way round, and then it gets to the end point here, and then it runs off with an arc movement. But all of those things can be set using the approach and run off buttons here and typing in the value. Okay, so when we're happy with that, we could post-process that and then send it to the machine tool. With the Lathe standard module, you can also run a 3D simulation, but that's not available in Lathe Basic. So that we'll choose a small lathe as opposed to a big industrial lathe. So that's creating the file to send through to the simulator. We can leave all of these defaults as they are and just press simulate. So that calls up the machine tool simulator, and then it passes it through the data. Okay, so that's the material. When we're running the simulator, we can show the stop as being transparent, or we can show it as solid. And then we just use the video controls at the top here to control the toolpath. So this is the roughing tool. We can speed up or slow down the simulation. And if we wanted to get rid of the small pip here, then we could obviously start at span number 1 and machine the whole thing. So that's the simulator, and then the last thing would be to post-process for your machine tool.